Expanding a logarithmic expression, problem type 2. The properties of logarithms and the way we work with the logarithms in this type of problem is going to be the same as in problem type 1. The one new thing we're going to add is taking advantage of the property of radicals that the nth root of a is a to the 1 over n power, and all of the work we can do with that. So the nth root of a to the m is a to the m over n power, and the nth root of ab is the nth root of a times the nth root of b. Right? Using all those properties of roots and changing roots into exponents will let us handle things like log of the cube root of x by rewriting that as the log of x to the 1/3 power, and then using the property of logarithms to bring that 1/3 out front and call it 1/3 times the log of x. Looking at something a little bit more complicated, if I have the log of the square root of 7x cubed over y to the 5th, there's a couple of different ways I can approach this. My personal preference is to call this the log of 7x cubed over y to the 5th, the whole thing raised to the 1/2 power, and then use the property of logarithms to bring that 1/2 in front. Then treat the rest of this expression the way we have before. I'm going to jump a couple of steps here, but this is exactly the kind of thing we did in problem type 1, where we're going to have the log of 7 plus 3 times the log of x minus 5 times the log of y, right? Splitting up the division to make subtraction, splitting up the multiplication to make addition, and then bringing the exponents in front. Right? That's all stuff we did in problem type 1, just jumping through it all so I can fit the rest of this problem on the page. Then finally, I have this 1/2 in front. I can distribute that through. And end up with 1/2 times the log of 7 plus 3/2 times the log of x minus 5/2 times the log of y. Right. So nothing really new to be scared of. Just remember those properties of fractional exponents and the property of radicals rewritten as exponents, and everything with logarithms works exactly the same.